The Bugatti Veyron is coming into the garage. My Bugatti Veyron. This is going to be the first time driving a Bugatti Veyron, and it looks like this. Didn't imagine it to look like this, but at this point we don't know what happens. So
from the very first moment this Bugatti rebuild story truly begins, one thing stands above everything else. The key system of the car has been locked by Bugatti itself, and that single action changes everything about what is possible next. This is not just a mechanical failure or a normal crash recovery situation, but a controlled shutdown enforced by the manufacturer to protect the vehicle systems after a severe accident. The moment the crash was recorded, the car's internal network immediately reacted, triggering multiple safety protocols across different electronic modules. And the most important of all was the locking of the key system and core control access. This means that even though the physical structure of the car could be repaired, the digital heart of the vehicle was no longer fully accessible without manufacturer permission. The Bugatti Chiron Sport, like all modern hypercars built by Bugatti, is not just a machine made of carbon fiber, titanium, and high-performance engineering. It is also a fully encrypted digital system where access to critical functions is tightly controlled through security protocols that activate instantly after crash detection. In this case, the locking of the key system meant that essential control modules, including engine authorization, diagnostic reset pathways, and safety system verification, were no longer available through normal workshop tools. This immediately created a situation where even a perfectly rebuilt physical car will remain electronically incomplete and legally unusable. The rebuild team quickly realized that they were not dealing with a standard restoration project. They were dealing with a locked digital ecosystem that required manufacturer-level authorization to unlock. This is where the story shifts from simple engineering into a battle between independent repair capability and factory-controlled software security. Every attempt to move forward had to be carefully planned around the fact that the vehicle's brain had effectively been frozen in a post-crash state. Even basic actions like clearing fault codes, verifying system integrity, or preparing the car for inspection were blocked by encrypted restrictions inside the body control module and related systems. This is what makes this rebuild different from traditional automotive projects, because no matter how skilled the mechanics are or how innovative the solutions become, the car itself refuses to fully wake up without external authorization. The key system lock is not a physical key problem. It is a digital access restriction embedded deep inside the car's architecture, designed to prevent unsafe operation after a major impact. And as the team began rebuilding the vehicle piece by piece, replacing damaged components and restoring functionality, this invisible barrier remained untouched, silently controlling the outcome of the entire project. From the very beginning, it became clear that the biggest challenge was not fixing what was broken, but convincing or bypassing the system that decides whether the car is allowed to function at all. That is what turns this rebuild into something far bigger than restoration. It becomes a test of engineering limits, software control, and manufacturer authority over machines they create. After the initial crash event was recorded and the vehicle systems detected severe impact, the Bugatti immediately entered a protective shutdown state that fundamentally changed the condition of the entire car, even before any physical repair work began. This is a standard behavior in modern hypercars, where multiple layers of electronic safety protocols activate within milliseconds to prevent further damage or unsafe operation. But in this case, the effect was far more restrictive than a simple warning system. The moment the crash data was stored, the vehicle's internal network began isolating critical modules, effectively separating the car's functional systems from its operational permissions. This meant that even though certain parts of the vehicle still had physical integrity, the software layer controlling those components no longer allowed full activation. The most important consequence of this was that the key authorization system became locked, and with it, access to ignition control, performance mapping, and diagnostic reset functions was restricted. This is where the involvement of Bugatti becomes central to the entire rebuild narrative, because unlike older vehicles where mechanical repair alone could restore full functionality, modern hypercars depend heavily on encrypted digital validation systems that cannot be reset without factory-level access. As a result, the rebuild team was immediately faced with a situation where physical restoration and digital restoration were two completely separate challenges, each requiring different levels of expertise and authorization. The car itself, a Bugatti Chiron Sport, was still structurally reparable, but its electronic identity had been placed into a restricted mode that prevented normal operation. This included limitations on engine startup sequences, gearbox calibration, and even communication between onboard control units. Every attempt to reconnect or reinitialize systems would result in persistent fault codes, indicating that the vehicle was still in a post-crash lock condition. What made this even more challenging was the fact that modern Bugatti systems are not designed for independent full resets once a major crash event has been logged. Instead, they are designed to require manufacturer verification, ensuring that only authorized service centers can restore full functionality. This design philosophy creates a strong dependency on official channels, which becomes a critical obstacle in a rebuild scenario like this one. For the team working on the car, this meant that no matter how much progress they made in repairing the physical structure, they were constantly being held back by invisible software barriers that could not be bypassed using conventional tools. Even diagnostic equipment from other high-end automotive brands was ineffective because the security architecture inside the Bugatti systems was specifically designed to prevent cross-platform intervention. This is where the true complexity of the project began to reveal itself, as it became clear that rebuilding the car was not just about restoring what was broken, but also about navigating a highly controlled digital environment where access itself was part of the challenge as the rebuild progressed beyond the initial crash assessment and into full mechanical restoration. The project began to show real physical progress that proved the car was not beyond recovery in terms of structure and performance capability. Damaged components were carefully identified, removed, and replaced using a combination of original specifications and cross-compatible parts sourced from different automotive platforms where necessary. This stage of the rebuild was where engineering creativity became extremely important, because not every replacement component could be obtained directly through official channels, and in some cases, alternative solutions had to be engineered to replicate factory-level performance. Despite these challenges, the physical rebuild started to come together, and systems that were once completely non-functional began to show signs of life again. Suspension geometry was restored, the drivetrain was reassembled, cooling systems were rebuilt using adapted configurations, and multiple electronic modules began communicating again after careful calibration. However, even as the physical condition of the car improved, one major barrier remained completely unchanged. The software-level lock imposed by Bugatti still controlled the vehicle's core operational permissions. This meant that while the car could technically be made to start or move under controlled conditions, it could not be fully restored to legal road status because critical systems remained in a restricted state. The body control module and related electronic systems continued to store crash data that prevented full system clearance, and every attempt to reset these modules using independent diagnostic tools resulted in failure or partial functionality only. This created a clear separation between mechanical success and digital restriction, where one part of the rebuild was progressing smoothly while the other remained completely blocked. For the engineers and builders involved, this was one of the most frustrating phases of the project, because visually and mechanically the car appeared to be returned to life, but internally it was still classified as a restricted vehicle. This disconnect highlighted one of the most important realities of modern hypercars. Physical repair alone is no longer enough to guarantee full restoration. The software architecture plays an equally important role, and in this case, it was acting as a final gatekeeper between a rebuilt machine and a road-legal vehicle. Every completed mechanical task brought the team closer to success, but without unlocking the electronic restrictions, the car remained incomplete in the most important sense. This is why the rebuild narrative began to shift from being purely about engineering skill to a broader challenge involving manufacturer control systems, regulatory requirements, and encrypted vehicle logic that could not be bypassed through traditional workshop methods. As the mechanical rebuild reached a stage where Bugatti could physically operate again under controlled conditions, the next major barrier was no longer inside the garage, but inside the legal framework that governs whether a heavily repaired supercar can be officially returned to the road. In the United Kingdom, any significantly rebuilt or structurally altered high-performance vehicle must pass a strict inspection process known as Individual Vehicle Approval (IVA), which is designed to ensure that the car meets safety, emissions, and construction standards before it can be issued a registration and number plate. This is where the project moved from engineering into regulation, because even a perfectly rebuilt car cannot be legally driven without passing this stage. However, the IVA process immediately introduced a dependency on the earlier unresolved issues, especially the electronic restrictions still present inside the vehicle. Inspectors are required to verify that no critical warning lights are active on the dashboard, that all safety systems are fully operational, and that the vehicle behaves consistently under diagnostic checks. In this case, the lock systems imposed by Bugatti meant that the car could not yet meet those requirements, because unresolved fault codes and restricted modules remain active within the electronic control network. This created a direct chain of dependency where the IVA inspection could not even be scheduled properly until the software-level issues were resolved. At the same time, the physical condition of the car also needed to be finalized before inspection, meaning that cosmetic completion, panel alignment, lighting systems, and exterior finishing all had to be fully completed before the vehicle could be presented as a finished unit. This made the IVA stage not just a test, but a culmination point that depended on every earlier step being completed correctly. The inspectors did not evaluate partial builds or incomplete configurations. They assessed the vehicle as a whole in its final road-ready state. This meant that even small delays in bodywork, custom fabrication, or electronic resets could directly delay the entire approval timeline. As a result, the IVA stage became a central bottleneck in the rebuild process, connecting mechanical restoration, software unlocking, and cosmetic completion into one unified requirement. It was no longer enough for the car to simply function. It had to function cleanly, consistently, and without any trace of post-crash restrictions. This is why the IVA inspection represents one of the most critical steps in the entire journey, because it is a point where all technical progress is translated into legal approval, determining whether the rebuilt hypercar can finally return to public roads or remain trapped in a state of incomplete restoration. As the rebuild moved closer to its final stages, attention gradually shifted from mechanical systems and legal approvals toward the most visually dramatic part of the entire project: the complete transformation of the car's exterior through custom-designed bodywork. This phase was not simply about repairing damaged panels or restoring factory appearance. Instead, it was about reimagining the identity of the vehicle itself. The builders made it clear that this was no longer just a restoration of a Bugatti Chiron Per Sport, but reconstruction of a unique, one-off version of the car tailored specifically to the owner's vision. This decision introduced a new layer of complexity because every external panel, front-end components, headlights, bonnet structure, roof sections, and even glass elements had to be custom manufactured rather than sourced directly from factory replacements. This approach significantly extended the timeline, because custom fabrication always requires design validation, structural testing, material selection, and iterative adjustments before final installation. Unlike standard parts replacement, where components can be fitted immediately, custom parts must be engineered to match both aesthetic goals and aerodynamic requirements, while still maintaining compatibility with the underlying chassis and safety systems. During this phase, the involvement of Bugatti remained indirectly significant, because although the manufacturer was not actively supplying custom parts, the underlying vehicle architecture still dictated the limits within which modifications could safely occur. Every design decision had to respect the structural and electronic boundaries of the original platform, ensuring that the final build would still function correctly once reassembled. At the same time, this customization process also created a synchronization challenge between bodywork completion and other ongoing tasks, particularly paint preparation and final assembly sequencing. The paint stage could not begin until the entire exterior configuration was finalized, meaning that any delay in custom panel fabrication would directly delay the entire finishing process. This made the bodywork stage one of the most time-sensitive phases in the project. Even though it appeared to be purely aesthetic from an outside perspective, in reality, it was deeply connected to both mechanical completion and legal readiness, because the final visual configuration of the car would determine how it is evaluated during inspection and how it is perceived as a completed vehicle. As the custom parts slowly moved from design tables into physical production, anticipation began to build around the final reveal, because this stage would ultimately define the identity of the rebuilt hypercar in its finished form, marking the transition from an incomplete engineering project into a fully realized, road-ready machine, the project, approached its final phase. The entire rebuild began converging toward a single decisive point where engineering, design, and manufacturer, authority all intersected. The moment the finished vehicle would either be fully accepted as road legal or remain partially restricted due to unresolved digital and regulatory dependencies. By this stage, the car had already undergone extensive mechanical restoration, structural reinforcement, and custom bodywork preparation. But one crucial layer still remained unresolved beneath the surface of visible progress. The electronic systems, still governed by lock control modules and post-crash restrictions, continue to define the boundaries of what the car could legally and functionally achieve. Even though the physical transformation was nearly complete, the digital identity of the vehicle was still partially frozen in its crash state, creating a mismatch between appearance and internal authorization. This is where the role of Bugatti becomes a defining factor in the entire narrative, because regardless of how much independent engineering effort had been applied, final system validation and unlock procedures remain tied to manufacturer control security architecture. Without resolution of these systems, the vehicle could not fully transition into a complete, unrestricted road-ready state. At the same time, the anticipation around the final visual reveal added another layer of pressure to the project, because the custom-designed exterior was not just a cosmetic upgrade, but a complete redefinition of the car's identity. Every panel, every structural modification, and every design decision contributed to a final form that would look significantly different from the original factory configuration, making the reveal a highly anticipated moment not only for the builders, but also for the wider audience following the project. However, this transformation could not be fully appreciated until all systems, mechanical, electronic, and legal, were aligned into a single completed state. The timing of paint application, final assembly, and system verification all depended on each other, meaning that no single step could be finalized in isolation. This interdependence created a final bottleneck, where even minor delays in one area could affect the entire completion timeline. As a result, the project reached a stage where progress was no longer measured in isolated tasks, but in the convergence of multiple systems coming together simultaneously. The final reveal, therefore, was not just a visual unveiling, but a confirmation that every obstacle, mechanical repair, electronic unlocking, regulatory approval, and custom fabrication, had been successfully resolved. Only when Bugatti's lock systems were addressed and all external requirements were satisfied could the vehicle finally be considered complete in both function and identity, marking the end of one of the most complex rebuild journeys ever undertaken. As the rebuild entered its final stretch, one obstacle began to stand out above everything else, not because it was the most visible problem, but because it was the only remaining barrier that could completely prevent the car from ever becoming fully road legal again. The body control module, commonly known as the BCM. Unlike mechanical damage, which can be repaired with tools, or bodywork issues, which can be resolved through fabrication, the BCM represents the central electronic brain of the vehicle, responsible for coordinating communication between nearly all major systems inside the car. In modern hypercars developed by Bugatti, this module is tightly integrated with encrypted software that records crash events and enforces post-accident safety restrictions. Once a severe crash is detected, the BCM transitions into a lock state that cannot be reset using standard diagnostic equipment, regardless of how many components are replaced or repaired. This creates a situation where the vehicle may appear fully functional on the outside, but internally remains restricted from full operation. In this specific rebuild, the BCM had retained crash data that effectively prevent the car from being certified as roadworthy, because regulatory systems require all electronic fault states to be fully cleared before approval. What made this obstacle particularly significant was the fact that it could not be bypassed through independent engineering solutions. Unlike other issues in the rebuild, where creative sourcing of parts or cross-brand components had allowed progress to continue, the BCM was governed by encrypted protocols that required manufacturer-level access to reset. This meant that no workshop tool, no external software, and no alternative hardware solution could resolve the issue without authorization from the original manufacturer. As a result, the entire project reached a point where all physical and visual work could be completed, but final functionality remained dependent on a single lock system. This created a dramatic shift in the narrative of the rebuild, because it highlighted the limits of independent repair in the face of increasingly software-controlled automotive systems. The BCM effectively became the gatekeeper between a completed engineering project and a legally recognized vehicle. Every other obstacle in the rebuild either had a workaround or replacement solution, but this final barrier represented a direct dependency on factory-level intervention. Without resolving it, the car could not proceed to final inspection, could not clear regulatory requirements, and could not achieve full road legality. This is why the BCM was not just another technical challenge, but a defining moment where the entire project depended on whether manufacturer access would be granted or withheld, ultimately determining the final outcome of the rebuild journey, the stage of the rebuild. Everything narrowed down to a single decisive dependency that overshadowed every mechanical achievement, every custom fabrication milestone, and every regulatory preparation that had been completed up to that point. The body control module issue had effectively transformed the entire project into a waiting game centered around one question: whether manufacturer-level access would be granted to unlock the final electronic restrictions inside the vehicle. Even though the car had been physically rebuilt to a high standard, with repaired structural components, restored systems, and custom-designed exterior elements nearing completion, the internal software environment still held the vehicle in a partially restricted state. This meant that the rebuild was no longer limited by engineering capability, but by access permissions controlled by Bugatti. In modern hypercars, this kind of dependency is built into the architecture itself, where encrypted modules and secure communication protocols ensure that critical resets can only be performed through authorized channels. While this design improves safety and prevents unauthorized modifications, it also creates a situation where independent rebuilds cannot fully complete without manufacturer cooperation. In this case, the BCM remained the final gatekeeper, preventing the vehicle from transitioning from a rebuilt project into a fully certified road-ready machine. Every other obstacle in the process had either been resolved or was nearing completion, including mechanical restoration, custom body integration, and preparation for regulatory inspection. However, without clearing the BCM lock, none of these achievements could be finalized in a legal sense. The inspection process required a fully reset electronic system with no active crash codes, no restricted modules, and no locked diagnostic states. This meant that even a minor unresolved software restriction could delay or completely block approval. As the situation developed, it became increasingly clear that the success of the entire project would depend on a single interaction with the manufacturer's secure diagnostic system. This moment represented a critical intersection between independent engineering effort and factory-controlled digital authority, where all progress converged into a final technical requirement that could not be substituted or bypassed. The rebuild had already proven that physical restoration was possible, but the BCM issue tested whether full digital restoration could ever be achieved without direct manufacturer intervention. This created a final layer of tension in the story, because the outcome was no longer about whether the car could be rebuilt, but whether it would be officially recognized as complete and allowed to return to the road under legal certification, the final stage of the rebuild. The entire project effectively condensed into a single defining requirement: the ability to restore full electronic authorization, so that the vehicle could pass all remaining legal and regulatory checks required for road use. By this point, nearly every physical aspect of the Bugatti had been addressed, from structural repairs to custom-designed exterior components, and the car was visually and mechanically approaching a complete state. However, the electronic foundation still held the entire outcome in uncertainty, because without a full reset of lock systems, the vehicle could not transition into a fully certified condition. The body control module, still in its post-crash restricted mode, remained a final unresolved barrier, and its resolution depended entirely on manufacturer-controlled access. In modern hypercars engineered by Bugatti, this type of system is intentionally designed to ensure that any major crash event triggers a secure lockdown, preventing further use until proper verification and reset procedures are completed through official diagnostic pathways. While this approach guarantees safety and structural integrity, it also means that independent rebuild efforts reach a hard limit when it comes to software restoration. In this case, the car could not proceed to final inspection, certification, or registration without first clearing this electronic restriction.